Jeg hedder Finn Rasmussen og er uddannet fysiker fra Niels Bohr Institut. Efter jeg blev pensioneret fysiklærer, har jeg arbejdet en årrække på en ny radikal teori om universet. De eksisterende teorier kan ikke forklare grundlæggende problemer ved universet. Derfor har mange fysikere arbejdet på at finde en radikal ny teori, som de kalder teorien om alting. Ifølge Carr-teorien har universet eksisteret altid og er ubegrænset. Carr består udelukkende af strømme af energi. Det tomme rum findes ikke, for her er umådelige mængder af neutrinoer, der strømmer med lyshastighed. De strømmer i rette linjer. Atomerne og elementarpartiklerne er også strømme af energi, men her er det roterende strømme. Carr-teorien er teorien om alting, men her i filmen skal vi kun se på 4 fænomener, som de traditionelle teorier ikke har kunnet forklare, men som Carr-teorien kan forklare ved almindelige fysiske love. Det er tyngdekraften, neutronerne, udvidelsen og lyset.
The first phenomenon is gravity. We know that an apple is pulled down towards the ground by a force of gravity. According to Newton, the force of gravity comes from the center of the Earth and acts over a long distance. Newton did not explain how the force could work at such a great distance. The Carr theory, on the other hand, explains that the force of gravity is due to the neutrinos in space, also called the cosmic neutrinos. Both the established physics theories and the Carr theory assume the existence of an enormous number of cosmic neutrinos. The neutrinos come from the outer edge of our universe. This animation shows neutrinos coming in slow motion from the outer universe and penetrating an apple. In reality, the neutrinos travel at the speed of light, and billions of neutrinos pass through the apple every second. The stream of neutrinos affects the apple with a downward pressure. There are just as many neutrinos coming from the universe below, but they lose some of their energy by passing through the Earth first. Therefore, they affect the apple with less upward pressure. The Earth shadows the neutrino stream, so there is a total downward force on the apple that we can calculate mathematically. This is gravity, according to the Carr theory. This animation shows the effect of the neutrinos on the particles in the apple according to the Carr theory. Here we see a neutrino hitting a nucleon in slow motion. In reality, it happens at the speed of light. The chevrons symbolize a flow of energy. The nucleon consists of rotating currents, and the neutrino is recorded as a rotating current. When the neutrino leaves the nucleon, a tiny amount of energy is left behind as kinetic energy. Every second, billions of neutrinos give a trace of kinetic energy to the apple, and consequently, the apple falls downwards towards the Earth. The impact on a nucleon from a single neutrino is so small that it cannot be observed in laboratories. The established theory therefore assumes that the cosmic neutrinos do not affect nucleons. Newton believed that both the force of gravity on the Moon and the force of gravity on the apple are due to the Earth. This is true, but the real cause of gravity is that the Earth shadows the cosmic neutrino stream. This animation shows in slow motion how neutrinos come from the far-out universe and pierce the Moon. In reality, billions of neutrinos are constantly coming from all directions, except the direction the Earth shadows. Because of this, there is a total force on the Moon directed towards the Earth, which we can calculate. This force maintains the Moon in its orbit around the Earth, and we call it gravity. The Carr theory's shadow effect is not included in Newton's law of gravity, and, as a consequence of this, the calculation of the force of gravity with Newton's law yields incorrect results in several cases. An example is that the outer edge of all galaxies has a large rotation speed that cannot be explained by Newton's law. This has puzzled astronomers for a century. To explain this, a mysterious, invisible, dark matter has been introduced, which is claimed to have 6 times the mass of the galaxy. According to the Carr theory, however, there is no reason to invent a dark matter, since gravity is determined by the shadow effect. Stars at the outer edges of galaxies experience a large shadow from the entire galaxy and thereby receive a large force from cosmic neutrinos directed towards the center of the galaxy. This gravity can explain the rotation speed.
Det næste fænomen, vi vil forklare ved hjælp af Carr-teorien, er neutronernes dannelse. Alle atomer består af 3 slags elementarpartikler. Det er neutroner, protoner og elektroner. Ifølge de eksisterende teorier, og også ifølge Carr-teorien, blev alle neutronerne dannet i det oprindelige univers, før udvidelsen. Først senere under udvidelsen blev mange neutroner omdannet til protoner plus elektroner. Kosmologien er læren om universet, og kosmologien må forklare, hvordan neutronerne blev dannet, og hvorfor neutronerne har den størrelse, som de faktisk har. I det oprindelige univers bestod det meste af neutrinoer, men energitætheden af neutrinoer var milliarder gange så stor som energitætheden af neutrinoer i vort nuværende univers.
In the original universe, which has always existed, neutral neutrinos streamed uniformly in all directions at the speed of light. The neutrinos were invisible rectilinear streams of energy with no spin, just like today's neutrinos. We do not know their shape, but here they are drawn as cylinders moving in the direction of their axis. They had different energy densities. They penetrated each other without affecting each other, like, for example, microwaves for mobile phones in our time. In the original universe, the energy density everywhere was as great as inside an atomic nucleus. If 2 neutrinos accidentally collided, they could merge. This created an eddy current called a pion. A pion consists of a spherical neutral Carr field rotating at the speed of light and an equally large neutral Carr field rotating in the opposite direction. Similar pions have been found in modern accelerator experiments. Pions had a very short lifetime because the neutral currents within them could split into positive and negative currents. Hereby, 2 partons were formed. The positive current in the partons, marked here in yellow, rotated one way, and the negative current, marked in blue, rotated the opposite way. The rotating electric currents in the partons acted like a small magnet. The two partons had opposite magnetic directions and repelled each other. Partons are the first particles that formed in the universe. Partons are also found in modern laboratories. They are the building blocks of all particles. All elementary particles were built up in this way by rotating currents that interpenetrated each other. Particles consist of rotating Kerr currents, whereas neutrinos consist of rectilinear Kerr currents. In the original Kerr field, it sometimes occurred that two neutral pions collided. The two pions could not fuse into one, but one pion could wrap itself around the other and form a double pion as a mutual flow of Kerr field arose between them. The neutral currents in the double pion now split into positive and negative currents. Neutrons, left, and antineutrons were thereby formed. Neutrons consisted of two partons with the same direction of rotation of the positive current, marked with yellow lines, and the opposite direction of rotation of the negative current, marked with blue lines. Antineutrons were constructed in the same way, except the positive and negative currents moved in opposite directions. An equal number of neutrons and antineutrons were produced. Neutrons and antineutrons, produced at the same time, had opposite magnetic directions and repelled each other. These neutrons and antineutrons enabled a new evolution of the universe.
Vi vil nu forklare udvidelsen af universet ved hjælp af Kerr-teorien. Ifølge Big Bang-teorien opstod hele universets energi pludselig i et punkt. Denne teori strider imod en grundlæggende lov i fysik, der siger, at hele universets energi er bevaret. Ifølge Kerr-teorien er universet ubegrænset og har eksisteret altid, og den samlede energi i universet er bevaret. For at forklare udvidelsen af universet har Big Bang-teorien indført en såkaldt mørk energi, men det er helt overflødigt ifølge Kerr-teorien. I Kerr-teorien opstår der et tidspunkt i det uendelige univers, et område med overskud af neutroner. I løbet af tiden så stiger temperaturen i dette område, og trykket stiger også. Og på et tidspunkt er trykket så stort, at der sker en kæmpe eksplosion af området. Jeg har beregnet, hvilken hastighed neutronerne får ved slutningen af eksplosionen. På den måde forklares udvidelsen af universet.
The book about Kerr describes a mechanism in the original universe where an area with more neutrons than antineutrons slowly started growing. This neutron area was the start of the galactic universe we know. Gravity was incredibly strong due to the great energy density in the original Kerr field. Neutrons that collided stuck together with gravity and formed black holes, shown here as large black circles. Everywhere in the universe, partons, neutrons, and antineutrons were formed. They gathered round the great black holes. When neutrons and antineutrons collided, we know that a large number of smaller unstable particles with large kinetic energy were formed. Such annihilations occurred in large numbers around the black holes, and high-temperature fireballs formed. These fireballs slowly grew larger and larger. At a certain time, the fireballs had filled the entire neutron area. The radius of the area can be roughly calculated to 1 light-year. When the fireballs had filled the entire neutron area, there was a huge explosion called Big Blast. All the fireballs gained speed away from the center of the explosion. The small fireballs gained a greater speed away from the center and penetrated through the large fireballs, which began to rotate. In the end, small fireballs disappeared completely into the outer universe. The remaining neutrons in the fireballs continued outwards at the speed they had gained in the explosion. The volume of the inner universe increased, and thus the temperature and pressure decreased. The energy density of the Carr field decreased, and thus the formation of particles ceased. The great fireballs later became galaxies with bright stars and planets, and one of them became our galaxy, the Milky Way. They are seen in the circle which is our inner universe. In the outer universe, the energy density of the Carr field is equal to its original energy density. Here the small fireballs grow ever larger, and their activity is recorded today as microwave radiation and cosmic neutrinos from all over the sky.
Det sidste fænomen, vi vil forklare ved hjælp af Carr-teorien, er lyset. For 100 år siden, på Einsteins tid, kendte man ikke til de kosmiske neutrinoer. Man mente, at lyset bevægede sig i det tomme rum som en elektromagnetisk bølge. Derfor kunne man heller ikke tænke sig, at lysets hastighed kunne ændre sig i det tomme rum. Det var grundlaget for Einsteins antagelse, at lysets hastighed er altid c, som han kaldte den, i forhold til en hvilken som helst iagttager. Denne antagelse, som er ubegrundet, er grundlaget for Einsteins berømte relativitetsteori. I Carr-teorien antager man, at fotonerne i lyset består af 2 strømme, en positiv og en negativ strøm, der bevæger sig parallelt. Hastigheden af en foton er afhængig af det felt af neutrinoer, som fotonen bevæger sig igennem. Fotonens hastighed er altid c relativt til det felt af neutrinoer, som den bevæger sig i. Dermed er fotonens hastighed ikke altid den samme i forhold til en iagttager.
In Einstein's time, different measurements of the speed of light were made in different directions and at different times of the year, all with the same result, c. All measurements took place near the Earth's surface, but the Earth's surface moves, and thus the observer also moves. This led to Einstein's assumption that the speed of light is always c, regardless of the observer's movement. Here, 2 photons are shown with opposite directions, but with the same speed, c. According to the Carr theory, a photon consists of a positive and a negative helix that move together in the direction of the axis. The Carr field near the Earth's surface contains neutrinos that come from Earth, and this Carr field follows the Earth's surface. Therefore, the result is c for all measurements near the Earth's surface. Out in space, however, the situation is quite different. Here, a galaxy with velocity, v, is seen moving away from Earth. The car field near the galaxy also has velocity, v. A star in the galaxy sends a photon towards us. The photon at the galaxy has speed c relative to the galaxy, and according to Einstein, the speed of the photon is also c relative to the observer. But according to the car theory, the speed of the photon is c minus v relative to the observer. In the space between the galaxies, the cosmic neutrinos move equally in all directions. Here, the photon therefore has speed c relative to the observer. According to Einstein, the speed of the photon is constant, c, but according to the car theory, the speed of the light beam increases from c minus v to c while traveling from the star to the observer. The wavelength of the light increases with its speed. In the car theory, the ratio of the wavelengths is used to determine the speed of the galaxy. According to Einstein, wavelengths are also used, but another formula gives a greater speed, v, for the galaxy.
Einsteins relativitetsteori har medført en beregning af galaksernes hastighed, som er for stor. Og derfor finder man, at galaksernes bevægelse er en accelereret bevægelse, som så skal forklares ved hjælp af den såkaldte mørke energi. De fænomener, der kan forklares med Einsteins relativitetsteori, kan også forklares med Carr-teorien. Carr-teorien er en teori om alting. Den kan formentlig forklare alle fysiske fænomener. Ja, teorien er enkel og sammenhængende og kan let forstås. Og den vil give mennesker en bedre forståelse af vort fysiske univers. Jeg har arbejdet alene på teorien nogle år, men jeg håber, at andre fysikere vil fortsætte arbejdet og forbedre argumenterne og beregningerne. Ligeledes håber jeg, at mennesker, der ser filmen her, får en ny oplevelse af universet.